Hello fellow teachers. I'm here with my partner Miss Mullis, and today we're going to talk to you a little bit about a high cognitive task for standards OA3 and OA7. There's always a progression when it comes to these tasks. There's a multiple entry points where it's accessible, the work should be accessible for any student. This is a progression of some work, samples that we've collected from our class. As you can see in this first work sample, this student needed to draw all in order to make a determination that 8 and 7 and 7 and 8 were the same number. This would be something that we'd expect maybe in the beginning of first grade, but we'd like students to start quickly moving past that as we introduce new strategies in first grade. This next piece of student work is a better strategy. They're counting on. It's something we do immediately in the beginning of first grade. So this student knew they were able to say 7 and 8 equals 15, and they just counted on. They started with the 8 and they added 7 more and they labeled them to show 15. And the same thing here. They started with the 7, they got to the 15, and they were able to agree. This is a great next step after your students have mastered counting all. This would be the correct progression. Moving on in first grade, by the middle of the year, a student should be able to start to see making tens. We work a lot with that friendly number 10 right from the beginning of first grade. It's a critical skill for place value. So this student, he did a really great job. He said he agreed because 7 and 8 and 8 and 7 are the same, and he showed it using an open number line. But what he did, he didn't just jump all of it. He jumped to his friendly number 10, knowing that 7 and 3 was 10, and then he jumped more to get to 15. He did the same thing here. He knew 8 and 2, and then he jumped the rest to get to 15, knowing that they did agree. The next step for this student would actually be decomposing the number. So if he had 7 and 8, we would ideally like him to break this down into 3 and 5. And the reason is that he should be able to see, the student should be able to see that that makes friendly number 10 and 5 more equals 15. That could also be done the other way when you take your 8 and you can decompose the 7 and do the same thing. This is something that your student should be working on about middle of the year. So decomposing that, it would also cause less mistakes and sloppiness and them having to draw and then explain and label. So this would be the next step for this student. This final student work that I'd like to show you, this student really has mastery of his friendly number 10. He writes, I know that 7 and 8 is 15 and 8 and 7 is 15 because I know that 7 and 3 is 10 and 5 more is 15. He does the same thing on the other side and he agrees. So although he doesn't have a lot of numbers, he's able to clearly explain his thinking using the friendly number 10. Again, we wouldn't want a student that's currently counting all to be able to jump right to something like this. It's very important that as we go from the pictorial and the concrete and we move up to the abstract, we take the student through the progression. This way we can make sure that they truly understand it and they're not just being compliant.